Okay, our today's topic is we need to find the equation of line in 3D, and this is the section number 12.5. This is section 12.5, and what we are going to do today, we want to find the equation of a line in 3D. As you have known from your previous knowledge, let's say if we are in a 2D space, that is we are in an xy plane, how do you find the equation of a line? How do you find the equation of a line? Suppose that this is the line L. In order to find the equation of this line, we need we need two informations. The first thing is we need a point on the line, that is the line L is passing through the point x0, y0, and the second thing we need is the slope of the line. That is, what do we need? The slope, which is given by, let's say we can find this dy by dx, and then we can find this the point slope form of the equation of a line, that is y minus y0 equals m into x minus x0, to find the equation of a line. So now the problem is the following. We are in a 3D space. Okay, we are in a 3D space, that is x, y and z, and we want to find the equation of this line. We want to find the equation of the line. So it will be kind of the same I mean the concept is same, but there will be a little difference. So this is the equation of a line. Again, we need two information: the point through which this line is passing through. So here, since we are in a 3D space, so let's say the line, it is passing through the point x0, y0 and z0. Okay, the second thing is the following, that we need a direction vector. We need a direction vector. Like in the 2D case, we need a slope of the line, but we need a direction vector. Now, what is a direction vector? It is a vector which is parallel to the line, or you can say we are given a direction vector. So this is, you can say, our direction vector v, which is given by, its components are given by a, b, c. So this is our direction vector, v equals to a, b, c. So we need two informations to find the equation of a line in the 3D space. The point and the direction vector. The next thing you need to do is to find the we need to find the position vectors. Okay, so the first will be the following. If we join this point with the origin, we are going to get a vector, and we will denote this vector with r0. So this is the position vector of the given point, and we assume any other point, let's say x, y and z. It is a point on the line, any other point, and we join this point with this this is the position vector of the point, any point on the line L. So how can we find the equation of a line? So there are three different forms of the equation of a line that you need to remember. The first one, it is called the vector equation. It is called the vector equation of the line. And the second one, it is called, we are going to call this the parametric form of the equation of the line. And there will be a third form. It is called the symmetric form. It is called the symmetric form of the equation of the line. So one by one, I will write their equations so that you can know what we are doing here. So what is the vector equation of the line? The vector equation of the line, it is given by this r equals to r0 plus t multiplied with the vector v. This is the direction vector v. Where what is t? T is any parameter. T is any parameter. Now, if we simplify this vector equation, we will get the parametric form of the equation of the line. And it is given by this thing: x equals to x0 plus at, y equals y0 plus b multiplied with t, and z equals z0 plus c multiplied with t. So this is the parametric form of the equation of the line. And then the number 3, it is called the symmetric form. The symmetric form, it is given by x minus x0 divided by a equals y minus y0 divided by b equals z minus z0 divided by c. So in the question, he will ask you anything. He will ask you find the vector equation of the line, or find the equation of the line in the parametric form, or find the equation of the line in the symmetric form. Any one of them he can ask you in the question. So let's do a question. So in this example number 1, what he is asking us, we need to find the vector equation and the parametric equation for the line that passes through the point 513, and it is parallel to the vector I plus 4j minus 2k. Okay, so you can think about this in the following way. Let's say this is our equation, this is our line, and it is passing through the point 5 1 3, and this line, it is parallel to this vector. Let us call this, we can denote this thing with v. It is given by I plus 4j minus 2k. What he is asking us, we need to find the vector equation. First we need to find the vector equation, and then we need to find the parametric equation of the line. So let's, first of all, we write the vector form of line. Vector form of the line. And from the above, we know that the vector form, it is given by r equals r0. r0 is the position vector of this point, the given point, plus t multiplied with this direction vector. And when we then we substitute these values here. So this is, remember, this is our point x0, y0, z0, and corresponding to this, we are going to have the position vector of this point, which is denoted by r0, and you can write this thing in the following way: 5i plus j plus 3k plus t multiplied with the vector v, which is given by I plus 4j minus 2k. And you have to simplify this thing and then rewrite this as a vector. What does it mean? It means that you can what does it mean? It means that you have to combine the I components, j components, and the k components. For example, on this side we have 5i, and here we have ti. From these two terms we take I as a common factor, and inside the bracket you can write 5 plus t multiplied with I, plus here we have this term, you can write j, you can use this symbol. This is just to denote them. Okay, 1 plus 4t multiplied with j. And similarly you can gather the k terms, and that will give you 3 minus 2t multiplied with k. So this is the vector form of the equation of the line. So this is your answer. The next thing is the following: we need to find the parametric equation. The parametric equation, or you can say the parametric form of the line, and we know that it is given by x equals x0 plus at, y equals y0 plus dt, z equals z0 plus ct. Remember here, here we have 1, so this is going to be your a, this 4 is your b, and c equals to minus 2. So the components of this direction vectors, that will give you the values of a, b, c. So so if we substitute these values in these, we will get the following: x equals to, what is x0? x0 is 5 plus a equals to 1, so we get here t, y equals 1 plus 4t, and z equals 3 minus 2t, where t is a parameter. T is a parameter, that is, it can take any value. You can substitute any real number in place of t. And in some question he may ask you to find the equation of the line in the symmetric form. So the symmetric form is also very easy to find. This is not in the question, but let's do this thing. So it will be equal to x minus x0. x0 is 5 divided by a equals to 1, and then we have y minus y0. y0 is 1 divided by 4, and z minus 3 divided by minus 2. So this is your equation, the symmetric form of the equation of the line. In the next question, he is asking you find any two other points on the line. So for this part number B, you can use the parametric form. So in order to solve this part B of the question, we need to find, let's say we have this line L. What he is asking you, find any other 2 points on the line L. So in order to do this thing, what you can do, you can use the parametric form of the equation of lines. You can use this parametric form. In the parametric form, you can substitute some values of t. For example, if you put t equals to 0, it will give you the same point which is given in the question. So choose a different value. Let's choose t equals to 1. If I put t equals to 1, what you have to do, you have to put these here in this in this set of equations. So that will give you x equals to 6, y equals to 1 plus 4, which is equal to 5, and z equals to 3 minus 2, that will give you 1. So we get a point A. Its coordinates will be 6, 5, and 1. Similarly, you can substitute any other, you can choose any other value of the t. Let's choose t equals to minus 1, and then x will become 5 minus 1, which is equal to 4, y equals to 1 minus 4, which is equal to minus 3, and z equals to 3, and minus minus become positive. 3 plus 2, which is equal to 5. So that is another point. Let's we can call this B, and its coordinates will be equal to 4 minus 3 and 5. 4 minus 3 and 5.